Welcome to DevSecOps Talks with Andrey
Paulina.
and no Matthias.
That was easy. Like without Matthias, it's much easier because you know what to say.
You have 50-50 chance.
Yes. Hello, everyone. Hope you're enjoying your summer vacation if you have one.
Yeah, it's quite hot these days, at least in Belgium. I don't know how is it in Spain. Are you dying from heat wave or?
Well, we're in Canary Islands, so it's a little bit away from Spain, and also Las Palmas, where I am, has the weather of its own comparing to the rest of the island. So it's actually quite fine here. It's like 25, 26 degrees.
That's
Nothing to
better than
complain.
here.
Yeah, so like I think south of the island is like 40 and
Yeah,
boiling hot.
I was boiling doing triathlon there, so 2 months ago. So
Yeah. It gets very hot in the south, but Las Palmas usually stay very cool because of the
so
clouds.
what are we talking today about?
We're talking about weather, obviously.
Yeah, how the weather connects to the pipeline.
Yes. So we thought that we're actually gonna give you an easy to follow episode and revisit one of the topics that we covered before, but I think which is like an evergreen topic, which is good to revisit, which is continuous integration.
And continuous delivery.
Well, let's see if we will have time to
Yeah.
get to continuous delivery. Let's start with continuous integration.
It always connects a bit at least, so.
Yes. And we assume that we might have some listeners who might be new to industry, and you might have heard about continuous integration and many organizations doing it today, but you might not have the background, why it's emerged, why it's important, what is the goal of it.
So, Andrey, you're much longer in the field than me. How did it look in the beginning?
Oh, I seen things, yes. I actually seen things that came before Jenkins, which were like very not nice. And Jenkins, when it was released in the 2000s, that was actually a pretty looking thing. Like a lot of people not share that opinion today, but back in the day, it was a huge improvement comparing what it used to be before. But this is like just integration server. I think we just need to look more generically why we are doing continuous integration. And that comes to the fact that we have multiple people working on a project and they have changes that they need to integrate together. What people actually been doing before continuous integration was like nightly builds. And I always tell the story that like when I was in Ericsson, we had a guy called Christian. Hello, Christian, if you're listening. And his job back at the time was to come at work very early, check the daily bills, and let Indians know before they check out that they broke something, so we can get a baseline of the build, the green builds, and we can test. So that was like the world. People will pile up stuff on the main branch, and then machinery will process that during the night, and obviously there will be issues because stuff is not integrated well together. The integration was happening during the night, so we were discovering issues post factum, and that's a problem. That's kind of preventing organization from moving much faster. Developers are not getting feedback about their changes, and this is how continuous integration emerged. So idea was that you would integrate every change. So one thing you could do, if, for instance, branching is expensive and version control systems that we had before Git were like that. So the branching was expensive. So you would just build every change that comes in, and then you find problems sooner. But then when the Git emerged, we got a possibility to actually receive the change in a central place without it affecting the main branch where everyone works. Used to be called master, actually back in the days, but yeah. you know.
That I remember the end of it
Yes.
when I was
So
entering. Well,
people were not happy
which
with the name for different reasons. And anyhow, you could pre-receive the change, and then you can run the build or test as you would do it on the main branch, and then see that it's actually buildable, and then you can merge it in, and you know your main will be protected and it will be always green because you integrate before the change come in. And that's what basically continuous integration is. So it's a way of us making sure that the main line stays stable, green. So if you check out the repository, you will be able to run tests because it will not be broken, that the build will not be broken, and you will be able to put your feature on top. So you can start working straight away instead of fixing stuff after other people who came before you and haven't checked those things, or maybe have not been notified that the build is failing. So the change was that you cannot come in to the main line without this check.
yeah, but developers can get quite creative about skipping the tests and the pipelines
Well, yeah,
unless you force them to not do it.
yeah, they can, but having this will cover like 90% of the cases, right? And in 90% of the cases, you will be nice and clean on the main line. And what is open up for you is testing. I mean, like you have some things that you know works to a certain degree, which means that you can now run more advanced testing, more expensive testing on top of that, knowing that you already tested the small things and the small things are working. So what people were doing back then is they introduced continuous integration, but then they would also have nightly tests. So they will have those long running test queues. And again, the same patterns. So you pile up stuff, you test it over the night, something breaks, someone need to come in and figure out what change actually broke the thing and file the test report. It could be even worse. It could be like a weekly testing, and then people start to create a test report or like issues, and then developers need to triage issues because no one already have a memory of what they did and who did it, who broke it. We need to figure this out. So the pattern emerged that you would then continue automating when you have continuous integration, and you would run as much testing as physically possible on every change. Because then, if you detect the defect, you can give a feedback to developer straight away. And if it's a trivial thing, you fix it to unblock the main. Or if it's more complex, then you just revert and main stays on a certain level of quality. With this, you're basically raising the level of quality of your main all the time. CI brings it to a certain level because yes, ideally you would test everything before it comes to main, right? But then the feedback to developers gets very, very long. So you want to have a balance there. So you might want to run like build, you want to run unit tests, maybe linting, static analysis, stuff like that. But then more advanced testing, like integration and end-to-end testing, if it's expensive, long to run, that probably will come already on main. Well, ideally on every change, but if it's too expensive, for instance, you're testing on hardware and you have like custom hardware or phones, for instance, then your testing capability will be limited to amount of hardware you got and how well it's automated, and loading software and hardware takes time, and so on and so on.
Yeah, but I think it also depends what are you building and how is your structure. Because yeah, okay, you wanna be balanced with it, but because I've seen both extremes, not having enough testing and both having way too much that you wait a few hours for small change to be integrated, even if you didn't change a lot of stuff. The test doesn't apply to particular change, so. You also shouldn't run everything on everything as well. And sometimes you have multiple or monorepos or repositories, which goes later on and integrate in the main repository on top of it,
One
where you deploy whole system sometimes. So it depends also how is it structured, your whole system, especially in more complicated cases, in my opinion.
Right. Yeah. So and like it's usually done in like if you take GitHub as example, I assume that most of the people are familiar with the GitHub. You create a branch, open pull request, you run the CI on a pull request, get the feedback, iterate until it's green, then you merge. So that is how it is nowadays. There are some deviations from that, but this pattern, I would say, emerged over time because where we started was a separate CI/CD server, and you would have a separate version control system. Well, the Git was distributed, so you could put it in many places, but like build crews and Jenkins and all of those stuff. What was TeamCity back of the day?
Oh, yeah, TeamCity.
So all of those, and I mean, there was like
Circle CI,
Circle
I think
CI.
there's a few. But I think, yeah, I still see the distribution between, having dedicated instance for CI, having, one for CD, or sometimes even two for CD, that you have non-pro for CD and production for CD separately. Especially in the bigger organizations, which are a bit more legacy, you still have Jenkins in use case when you have more centralized set for it.
Yeah, so if you don't have money for GitHub Enterprise, yeah, you're on Jenkins. But that seems to be a common pattern now that people are combining version control server with a CI/CD server. So it's like one thing, and because then developers don't need to jump between systems to see the status of their build, how it's being integrated, and so on and so on.
And also the responsibility, it's more distributed, at least for the CI part. Usually the team is more responsible for it versus the centralized team, which only do pipelines,
Well,
as I've seen in the past in some organizations.
depends. Well, nice thing about GitHub Action is so a lot of CI/CD servers, their philosophy is that you get one file, one CI/CD pipeline, whatever file per repo. Like for instance with Jenkins, I don't know if that changed, but back in the day you could only have like one Jenkins file per repo, and that was it. With GitHub Actions, you can actually have multiple pipeline files. And what usually happens is you would have still someone building those pipelines centrally and using, reusable pipelines from that central repository to do mainline stuff, like the main CI/CD criteria, and then beyond the merge. But multiple files, multiple CI files and repository allows teams to add extra files there on top of what's created by the centralized team. And if they want to do more in CI stage, they can do that without bothering the centralized team. So there's actually a lot of flexibility with this approach. Like the having a multiple CI files is amazingly powerful concept that I feel is not being appreciated enough and noticed enough.
Yeah, also if you compare, for example, for Jenkins files and Jenkins pipelines, which can get very complicated very fast, and that can create a lot of issues, and you need to usually keep the shared library for all of them for the particular instance, and usually the teams are not too happy about it because they want to have it more customized, and that's what GitHub Actions give you. For example, GitHub Actions gives you much bigger flexibility without influencing everyone with it.
Well, I would say it depends how you cook it.
Yeah, it always depends, but I think the principle. It's the general principle. It's usually I see that these use cases, how it's used, is usually differ a bit.
I would say that the centralized pipeline management is necessary at scale, right? So you
Yeah.
have like a golden path if you have, I don't know, 500 repositories, and you don't want every team with 5 to 10 repositories running into the walls trying to do CI/CD. You want to give them a golden path so they don't need to think. They just drop this file into the repository. They know they can deliver to the correct environment with correct configuration. They don't need to think about it. If they want to do custom stuff, they can still do that. It's kind of the same with Jenkins, but what's dangerous with Jenkins is like the Jenkins files used to be groovy. So, well, it's kind of, it was like DSL, but you can also go all the way to groovy, and then you could do whatever. It's a full-fledged programming language, and I've seen people doing amazing stuff with it. But also, it's very easy to shoot yourself in the foot. Like the YAML-based pipeline, that's like seems to be a default nowadays. They put the guardrails and limitations on you, but those are useful because they prevent you from hurting yourself. So you just, like if you are a driver, like so you can drive the normal car fine, but then suddenly you dropped into Formula One car. Like you have no idea how to drive that car. And that's what was with the Jenkins file. So it's like all the power of Formula One, but you need to be a Formula One pilot for it to work. Very good. Because if you're like a regular guy, that's just very confusing and you can easily crash. That's my take on the scripted pipelines.
No, definitely. And also, like, I agree what you were saying that, if we have scale, then you need to start centralizing some stuff. So not everyone is doing everything, and you need to keep a certain standards within the organization and ensure that it's secure, that it's updated, and so on. But you don't need it on the very small scale. What I've seen people are also doing. Sometimes you over engineering. You have one pipeline, you're gonna do shared library for it. It's kind of stupid.
Well, it depends on people, right? Like if they really like to do CI/CD, they're gonna do CI/CD. So what you gonna do?
No, I think you should do CI/CD always, but how you do it, sometimes I've seen it a lot over engineering, that you spend a lot of time on code versus delivering the business value as well. So, there is always this balance, business value versus technical value, which you could do something much simpler.
Right. If you want to talk about over engineering, there is one concept which you see kind of rarely, but it exists. I mean, like its implementation. It's called merge queue. I actually implemented it few times myself. Now you like in Gerrit, I think. Yeah, I did it back days with Jenkins and Gerrit. Now GitHub has actually support for merge queues, if you were not aware. An idea here is that you're shifting a lot of testing left, or your testing is heavy, so you cannot complete it quickly. But the rate of changes that coming in is actually higher than the rate of your CI/CD. Like your bandwidth of CI/CD of testing, maybe you like limited to the piece of hardware you're testing. Like you have 3 pieces of that hardware, and you can test only on those. You can ask yourself, why would you want to do CI/CD on the hardware? That might be one question, but depends on your risk profile. And some organizations choose to actually test more before it comes to the mainline, and then the need for the merge queue emerges. So what happens is you have a pull request. Imagine you have a pull request, and you say, instead of just running CI/CD, you will have a button, I want in. And that puts you into the queue. And queue basically takes, you have a server that takes a commit from the queue, puts it on top of main, tests it. If everything is passing, it will automatically merge it. If not, it will discard the commit and send feedback to the pull request. Take a next commit, put it on top, test it. If it's working, it's going to merge it, and so on. And it just works through the queue. And then usually you would accumulate commits during the day, and then the queue will merge all of that over the night because there is nothing coming in during the night. So I've seen that happening. I actually built a couple of those. In my experience, it was only needed for like embedded stuff where there was like limitations in the test targets, and actually breaking main was really painful for everyone because it like was hard, and you didn't want to do that, and then organizations needed to do this kind of stuff. But that is an existing concept. You don't see it very often, but if in your organization you're struggling to integrate, but it's very important for you to keep main green, buildable and testable all the time, that's actually a valid concept to adopt. Have you seen the merge queues anywhere, Paulina?
No, not really.
That's
I've been
a
quite a few
rareness.
organizations, but it's rare.
It
The
is.
thing, I would see it more for the hardware testing, maybe.
Like the
Because
also higher risk profile. So if you like, if you are medical field, for instance, then you might like if you're doing like the software that goes into medical devices, so you're like FDA regulated, you might want to do stuff like that. So you want to test
yeah.
more.
Yeah, but for the regular, I've been on the, customer who was medical device regulated, and they had a very long process to being able. So you could, merge, you have a lot of tests, but to being able to release anything, there was whole process which needs to be approved and so on.
Yes.
So the particular version wasn't so hard to get merged, but you have very long running tests. But to being able to release it to devices and roll it out, that was very complicated, as you needed a lot of paperwork and so on.
Yep. But basically, continuous integration, like going back to from what we have started, is something that you do when you have multiple people working together on the same project and they're pushing changes that needs to be put together and make sure that they actually work together and don't break stuff for each other. If you work alone, technically you don't need continuous integration because you are integrating on your own all the time. But it's good to have, in a sense, if you miss something, then centralized server will spot it and give you a feedback. One pattern that also emerging now, which is relatively new and like what we do quite a lot nowadays, is you would have, for instance, GitHub action, like using GitHub as example, and it's possible to install Cloud Code or Codex to the GitHub action runner. So it's just a JavaScript package. And then you would basically run Codex or JavaScript to run a review for you in one way or another. If you want to see an example of that, we have in 5XL, go to GitHub 5XL, and there will be a repository, shared workflows. So you will have an example of such AI review workflow where we're using AWS Bedrock as a backend to provision the model. So you don't need to have like Anthropic API key, OpenAI API key. You just consuming directly from the Bedrock, and all the data stays in AWS, not being shared. Blah blah blah. So you put code review in there, but what you do is you would have your local coding agent with a skill. So in a skill, you explain, like you open the pull request this way, then you wait for the build to finish. If build fails, you fix the build. If there are any inline comments left by the AI reviewer, you debate it with it and come to the best possible outcome. So this is how you can put two AI working together against each other. Well, working together against each other doesn't really make sense, but anyhow, you see what I mean. Then they can iterate on a pull request by feeding by feeding the comments to each other, and then you just need to come back and test and check what's left, right? Because still they might be going in the wrong direction, but you will have still much less work to do as a human reviewer comparing to just doing everything yourself. And AI is missing stuff all the time, even like the best models missing stuff all the time. So this is very helpful. Like this feedback loop is very helpful, and this is how you
Yeah,
utilize what you already have as a
yeah, I work with it
structure.
quite a bit as well, and I think you can also another thing you can make it if you wanna, for example, have even a few code reviewers to being specific in something. So, for
Yeah.
example, we have one for testing, one for the security point of view, and so on. And also, of course, getting the particular guidelines, what you want to have it to focus on, and so on, and being able to ensure that you have a guidelines also in your repositories, like how the AI should code with it, or what you want to, in what way you wanted your code to be structured within the
Yes.
repository. For example, function reusable, updated documentation, test coverage for everything, security checks, and so on.
So that's a new pattern where you reuse what you already have, like your CI/CD, right? So you might have some security scanners there already, but now you're adding the automated code review to make sure your change is good to go and contains less possible issues than it would otherwise. And yeah, the quality of AI generated code, I don't need to tell you. It looks good, but there are subtle issues that will bite you in the back.
Yeah, or you're going in the, especially if you generate a lot of code, from my experience, then you have to go through a lot of review rounds. I was adding quite big functionality in one place, for 40,000 lines, and the review process was very long, because you're going, you fix something, reintroduce something else, you
Right.
fix something, reintroduce something else. So, and you need to be in the loop as well, because it's something what it didn't have a pattern of, so you want it in the particular way, and it can have quite big impact, but the it's also changing where you're spending your time a lot right now. Like reviewing, I think it's much, versus the generating the code. So
Yeah, you could basically decide how you do it, because if you do interview ahead of time, so you like align with AI before the code generation, then you need to spend less time on code review.
yeah,
So that's like one
yeah,
of
but
those things.
for that you need to have very specific requirements, and that sometimes can be tricky depending on what organization you're working with.
Right, right.
If it's from coming also from business side, it may be more tricky versus if it's only technical part of it.
Yeah, but one thing that Paulina is mentioned is actually one of the best practices in software development is you want to have your changes being small. You want to do small incremental changes, so it's easy to review, easy to integrate. If something fails, it's clear where the problem is. Because if someone dumps on you like 30 line change, you're like, whoa, dear person, what do you want me to do with it? It's not humanly possible to read.
Git cannot also handle it. Git is, if you're going over a certain number of changes and comments and reviews, Git it's very annoying to being able to handle that big PRs. So the
Yeah.
smaller the better.
And I mean, like, it's not only AI that is doing that. There are humans who would just disappear for a month and emerge with this, like, look, I've been busy. Now someone need to review this stuff. And like, no, that's not how things are done. You have to do it in small pieces, like split in small pieces and deliver it as a small piece. Anyhow, up at the time, so that was a review of CI/CD, and there was an article. If you want to hear more about CI/CD, or about CI part at least, so for CI there is a great article by Martin Fowler. Our show note writer gonna find the article and link it in the show notes on DevSecOps FM. And for CD part, there was a book by who was by David Farley, I think.
So,
Just like missing his last
David
name.
Fairley and Jess Humble.
And just humble. He was a rock star in CI/CD days, on all the conferences and doing really good talks. If you can find one of his old talks, like back from 2013, then it's a good to watch. With this, we're gonna leave you and let you enjoy your vacation.
Bye.
Enjoy. Bye bye.
You have been listened to DevSecOps Talks with Matthias, Andrey, and Paulina. For notes and information, please visit devsecops.fm. Thanks for tuning in.